Hi and welcome to another episode of TRX Bench. Today I just want to show you a little concept and a little experiment on RF amplifier for CB radio receive. Okay, so I have been asked recently, is it possible to get a preamplifier for receive into my CB radio, because most of the CB radios do not have something which is amplifying the incoming signal. And I experimented here a little bit and tried to get a good result, and that is what I want to show. What I wanted to show you today, because it is not really that difficult. And to say it right from the beginning, this what we have here are all old concepts, so it is nothing new, and it don't need to be new. The most important point is that what we have here on the bench, is it really performing as it should, or is there something where we would say, it doesn't work, so we simply leave it alone. So let's see first of all how it works, and then let's go a little bit into the concept that you understand what I've done here. Okay, and first of all, it is a simple CB radio. This is here my test and demonstration radio, so an old Albrecht, but the concept can be used for any radio. And of course, I've set it to channel 4. We simply need a channel where we can do this testing. Okay, and let's see what we have here. So you can see that the generator is sending into the radio on channel 4, which is 27.005 megahertz, right? And I'm sending here with minus 73 dBm, because that is equivalent to an S9 signal, right? And you see here the synod value, and it is a normal CB radio synod, so they are always around 26, maybe 30. So that is what we have here on. So that is switched to FM, but it doesn't matter if it is running on FM, AM or whatever. So this is a very good reception condition, and when I switch in here the speaker, so you can hear, it is a clear and loud signal. And we see it here that we have really a nice and clean sign, and everything is good. So no reason for an amplifier. So in this case, you always want to have the amplifier switched off. But now let's go into the noise, and that means, let me here increase a little bit the audio, and now let's go into the noise. And while we go down with our signal, you will see that our synod is dropping, and there is a rule of thumb that a 10 dB synod is still a signal, or is always a signal, which can be good heard on the radio, right? And therefore here let's simply go down here, and now we are at minus 120 dBm. And for all of you who want to know what it means, minus 120 dBm, so that is 0.22 microvolt, okay, 0.22, also 0.22 microvolt, or with other words 220 nanovolt. So you already see it is a very tiny signal which is going into the radio, and we still are able to hear the signal, but you see already here on the monitor, can you see it? I hope that you can see the signal, and it is getting more and more noisy. And now let's go more into the noise, and I'm not sure. Yeah, maybe a little bit in the background we still hear the signal, but that is now definitely a signal which can't be heard on your radio. So if someone is transmitting a signal which produces only, I don't know, 2 dB, 3 dB synod, then you will really have a hard time to understand what your partner on the radio is trying to tell you. And that now is the point where it is really nice to have you know, an amplifier, a receive amplifier, right? And it is not common in CB radios. All the ham radios have an amplifier, a pre-amplifier for really difficult receive situations. And now you really want to have a good working pre-amplifier. Okay, and that is now exactly what we want to try. And of course I show it to you in a minute down at the circuit, but let me now switch in here our pre-amplifier. And look at this. Now we have back a more or less clean signal. Remember how deep we are in the noise. So that is really minus 125 is only 0.13 microvolt or 130 nanovolt. So that is so far down in the noise that it is really difficult to receive, even for a ham radio. So even a ham radio is struggling with signals so low. So therefore now you see with the preamplifier on, we suddenly are able to hear again the signal, and we are picking here our synod of 10, which is really needed to understand your partner, right? And therefore that is the only performance which is telling you, is your little preamplifier working or not. So let me switch it off. Now it is off, and you see everything is dropping. Now the signal is back, very noisy, and you can't really understand it. Amplifier back in, and wow, it is working and you can understand. That is definitely the situation where you use your amplifier, and you will not use it with a strong signal. That is not a good idea, but always with a very low signal. This amplifier is able to help to get the signal back out of the noise. Okay, and I've put it here all in our little project box. And once again, so what I've done here is only a concept to show that it is working, and that it is really helping you to have something to get a better reception in difficult situations, right? And it is outside the radio, so we do not need to touch the radio just for here voltage supply, right? And of course we need to switch between transmit and receive. I will show it in a minute to you how that works, but let's once again hear what we have. So now you hear the signal is readable, and now let me switch our preamplifier off, on, off, on, and I think you already hear that there is a huge difference between receiving without our little amplifier or with the amplifier, and therefore we already see that this little amplifier, which is built in here, by the way, old school, but I will show you that in a minute. So it is really easy to build, and this concept here is for radios without an own transmit receive relay, because you see here in the radio there is no transmit and receive relay. So if you have a transmit and receive relay in your radio, then it will be more easier, and maybe you can of course put your little circuit, your preamplifier, in your radio if your local rules are allowing to do it. So in Europe for CB radios it is not allowed to open them, but as long you have here an external box which can be connected to the radio, then it is fine, because it is only a receive amplifier, not a transmit amplifier, so no problem whatsoever. And well, you see it can be attached here to the radio, and yeah, it helps you in difficult situations. Really, all what you need for your amplifier is what we have here on the bench, right? So it is basically a relay, and we have here some components. We have here capacitors, and we need a little transistor, and then it is working. So that is definitely all what we have. And all what I've used is here, you know, the preamplifier, which has been built in for years in the old Texas Star amplifiers. So here, for instance, the DX250 or DX350. And these amplifiers always had built in a simple one-stage preamplifier for receive. And I have a little bit experimented with this amplifier to see how it performs, because basically, you know, it is so simple, and always you have the question, does it work or not? And I can promise you it works, even if the parameters are not that you know, good, but it is working, because the only indicating or not indicating, so the only proving figure finally is our synod, and you have seen how much the synod improved, and that is all what we have to take under considerations. But let's look here. By the way, this is here the page cbtricks.com, right? cbtricks.com, for all of you who might not know this internet page. Is it mentioned there in, yeah, up there in the corner up there? You can read it, cbtricks.com, and under Texas Star you find all this nice information, and there you find as well really nicely improved schematics. So somebody obviously has redrawn the original schematics, I believe, because that is, as you can see, really well done. So for instance, you get here all the informations on the transformers, so output and input transformers, and how to build it. So really well done, and therefore that is sometimes a great source of informations, okay? But we are more interested in the little amplifier, and therefore let's zoom into our amplifier, and what you can see here, that is the little amplifier we have. Why can't I move it? Let's see. Ah, now it's working. Great. So what you see here in the middle, so that is the whole amplifier, and you can see as well that the transistor which has been used here is a 2N4125. So that is originally not an HF transistor, but it is an audio. Yeah, primarily it is an audio transistor, but it can be used up to, I believe, 100 megahertz, so I'm not entirely sure. But anyways, once again, it is not known as HF transistor, but it works as HF transistor. And what you see here is basically a very easy schematic of our amplifier. It is well known, but the drawing, what they have done here, is maybe a little bit misleading, because you might have problems to understand how it works, and therefore let's have a look in a different drawing, and then I believe it might be easier to understand. Yeah, and here you see the same schematic, but I've drawn it a little different, and now we can more easily see that that is really a basic schematic, or a root one-stage amplifier, very simple. So we have here our input with a coupling capacitor, and we have here our output again with the output coupling capacitor. So we have here our 13.8 supply voltage, and we have here our PNP transistor. So you can use a BC557. It is a PNP transistor, or of course you can use the original 2N4125. And this concept here is with negative voltage feedback, and that helps very easily to hold the working point in place, because all components will drift with temperature, and so these little transistors will do as well. But with here the negative voltage feedback concept, you can stabilize your working point, and therefore that is all what it is. So it is really so simple that you really you can look up this concepts, this little signal amplifiers in all electronic training books, and you always will find this schematics. So with negative voltage feedback, or the same is or another concept is with current, with negative current feedback. So that is then a little bit different to what we have here. But once again, this all are simple and easy one-stage amplifiers. That's it, very easy. And we can build it as easy as it is here. And yeah, let's look a little bit into that. And as I already said, this is here the old school concept. So we simply take all the components needed, and we solder them together and hook them on a relay, because we need the relay to switch between amplifier on and amplifier off. Remember, it is not a good idea to switch the amplifier on if you have already a good receiving signal. So with a switched on amplifier, if you don't need it, you create different problems in your receiving pass in your radio. So therefore you really need to have a switch, what I have here, and there you can switch it on and off when it is needed. And another important consideration is, of course, so this is a front-end amplifier, and this kind of amplifier will of course everything amplify which is unwanted as well. So if you have QRM, right, then the QRM from I don't know, from LED lamps, or from bypassing cars, or from switching power supplies, or what else do we have in our houses today which creates a lot of noise. And of course an amplifier can always only amplify what will be here at the input. And if there is a lot of crap and a lot of QRM, of course an amplifier, and it doesn't make any difference what kind of amplifier you are using, so it will definitely amplify all the crap as well what you don't need. So that is a reason why many operators stating that I do not need it and I do not want it because it is amplifying all the crap. And yes, it is the fact that a front-end amplifier is always really amplifying all the crap. But if you have really not a lot of QRM, right? So if you only have a tiny signal, then definitely an amplifier will help. And of course there are other concepts. So you can, for instance, I have here, I use it as test amplifier. So that is a modern MMIC, so a monolithic amplifier, which is basically having the impedance adapted both at the input and at the output, so 50 ohm input, 50 ohm output, and therefore this MMICs, these monolithic amplifiers, are state of the art, but they are a little bit more expensive. When you get this basic transistor for only some cents, you have already to pay for an MMIC a couple of dollars, depending on what you are buying. But this modern monolithic amplifiers can't do any difference. If there is crap at the input, okay, then also a monolithic amplifier will amplify the crap. So that is a matter of fact, and we really can't change it. So therefore, save your money and build this little easy amplifier. I have tested it before. So this amplifier will amplify by 20 dB. So that is not bad. My little monolithic here is amplifying by 30 dB. So that is stronger. But I have compared this both. The results are not really much better, and that might depend also on the cheap concepts of CB radios, because the input matching into the CB radio is not always really 50 ohm, and we have some ham radios which have also not a very good input matching. So you know, the result with the mic is not really better. So you really can use this little cheap transistor, basic transistor amplifier. Again, all what counts is at the end the synod. The synod is our proving value, and therefore, believe me, this works. Even if the input impedance of this little circuit is not really good. I've tested it with my network analyzer, and the input impedance is not really good, but that all doesn't make any or doesn't matter, right? Because we are able to improve our signal to noise, and that is all what we need, and that is what we have proved. All right, so let's look now a little bit more into what we have to do down there. Okay, this is a schematic, and that means here we have all the components we need, and of course we need a relay. So under my construction, under this amplifier, we have of course sitting the relay, which is switching between amplifier on and amplifier off. All right, and therefore we can directly build it on our relay, and that makes it relatively simple. And here is our build plan. So don't be confused, it looks more complex as it is. Really, it is not very difficult. So what you see here on my drawing is 1, 2, 3, 4, 5, 6. So that are here our contacts, okay? And then we have down here the relay coil itself. So when we switch it on with 13.8 volt, then the relay get engaged and the contacts are switching. And yeah, this relay has two independent lines. So we have here our middle contact, and it is then simply a contact which is switching between here and here. So basically it is, let me try to show it. So you have two contacts. Let me show it this way, and then you simply flip between this both contacts, and that is what we have here. So that is, if you like, the middle contact, so this one, and then you have sitting here a relay contact up there and one down. So that means if it is not engaged, so no voltage to the relay coil, then it is sitting on one contact, and when you switch it on, then it is flipping over. So that is the whole secret. So that is very simple. Maybe we can draw it once again. So if we have here our three contacts, okay, so this is only one side, and this here is our middle contact, okay, and now this middle contact will switch this way, okay, or it will switch to the other way, and then this both are connected, or if it is on the other contact, then of course this both are in contact. And that is the whole story, what a relay is doing if it gets switched in or switched out. So therefore very easy basically. And what we need is now that we put a signal into our relay and we put it out, and what we want to have are two states, if you like. So let me see if I can show it more on this here, because that is the whole story. So this is representing our little amplifier, so that is the symbol which is used for illustrating an amplifier, right? Or we simply have a bridge, and you see we have here 1, 2, 3, 4, 5, 6 contacts, and that are our 6 contacts which we have here on our relay, okay? And you see here the, is it called wafer? I don't know, which is flipping over, and that is exactly what I've shown you. Now the contact is flipping between these two stages, and therefore you see we can bypass here our amplifier, and that is simply a bridge, okay? Or if we engage it by switching on our voltage, then the contacts are flipping over and our amplifier is switched in. So that is the whole idea. Here in our little circuit we have here an additional relay, and that is nothing else than the transmit and receive relay. And that is very important, because if we transmit, so that means we are transmitting, of course, in exactly the different direction than we receive, and we cannot transmit into our little amplifier, because for two reasons. First of all, we would kill our little sensitive pre-amplifier for receive, and therefore we would destroy it, and therefore we need to switch here our transmit and receive relay on bypass. So that means we need to bypass our little amplifier, and that is all what we are doing here. So when we are pressing our PTT switch, in that case, of course, we need to switch here our transmit receive relay simply to bypass here our complete receive amplifier. So that is the whole idea, and therefore I have here a second relay installed just to be able to handle transmit and receive. How does that look in our schematic? Once again, very easy. So we have a second relay like this one. So simply we could add here a second one, no problem. And again, you see the red line here is the transmit line, and when this is here our radio, right? So we will of course transmit to our antenna, right? And if we receive, then we want this relay to switch over to receive, and then we have here our amplifier in our receive pass, independent if we have switched it in or we bypass our receive amplifier. But in any case, we are using this way for receive, right? And as in the moment we are pressing the PTT, right, this relay is switching over, and we are bypassing here our complete receive pass right to our antenna. So once again, this is easy as well, because it is the same relay. It is basically exactly here the same switching between these both contacts, and that's it. So no problem whatsoever. And therefore, if this here is our transmit and receive relay, so that is now we have done it again here with the real contacts. Okay, so we have here our 6 contacts, and down here, so this is our coil which is engaging our contacts, and you find in this configuration again what we have already seen here. Okay, so you see again green, which is our receive. So that means we have to have our antenna connected here to the contact of our relay, and you see if the relay is not switched on, then the contacts are on this contact, and we can simply here go through our receive amplifier, and of course we need to go into our radio. So therefore we are picking here our signal again and connect it into the radio. So that is basically here our input, and from the antenna, and then here our input to the radio, and that is what here our schematic is showing us. Okay, and if our relay gets engaged, then this contact here is flipping over, and now we are on the red lines here. So now TX, and we are sending of course into this direction, and that means that now over this bypass we are simply connecting our signal to our antenna. And again here, back to our real circuit. So you see here the bypass bridge, okay, and you see here the input from the antenna, and here the output to the radio, and of course transmit, then it goes here over our bridge, and if we are on receive, you see then is our front end amplifier in the circuit. So again with input, right, and with output out of our amplifier, and then connected via our relay to the radio. So that is basically the whole story. Well, additional to that, you see here a little transistor, okay. We have here our 13.8 volts connected to our relay coil, right? And of course this relay only is allowed to switch when we press PTT, and therefore we have this little transistor here, which is switching in our relay simply by the information over the PTT, because this here, the white wire, is coming here from our radio, and that is simply here the connected microphone. So you see here is our microphone jack, and here from the inside I'm picking here our PTT signal, and when I press PTT, this line goes to ground, and as it is a PNP transistor, which is here sitting on our relay, it will switch through, and our relay is finally engaged. And that is what you can see here. So again, we have here our both contacts from our relay, right? So our coil contacts, and we have of course here our diode switched to the relay, so that at this point we are connecting our plus line, our 13.8 volt, okay, and here on minus or ground we have sitting our PNP transistor connected to ground, and at our base we have a 10K resistor, and now when we press here our PTT, right, we pull over the PTT, we pull our base to ground, and if the base is pulled to ground with you know, PNP transistor, then it will connect through, and our relay will work. So therefore this is finally how to connect it in real life at your relay, right? And that is finally our schematic for it, and you can use here exactly the same PNP transistor. So here in Europe BC557, or in the United States you can use the 2N4125, which is exactly the same which we are using here in our little amplifier stage, okay. And now once again, this may be a little bit confusing stuff. Let's look into this, but it is not really difficult, okay. So our first step will be that we draw what we have here without the relay underneath. So this is more or less already how it looks like when you have the relay under your little amplifier. But let us first draw this here without you know, the relay under it. Then it might be much easier to see and to understand. Okay, so maybe this is a little bit more easier for you because we only have here our 4 components. So this is here our 100 nanofarad capacitor, so 104. So that is what we have printed here. Let me see if we can show it. Don't know if you can see it, but that is here our 100 nanofarad bypass capacitor here, and we have here our diode, and watch the marking on the diode. So here is black marker which goes here down to plus, and that is the cathode of our diode. Here's our anode, this is our cathode of the diode, and the marker is always on the cathode, and it needs to go here to our plus connection. And this here are our little, I'm using disc capacitors, but you can use basically anything you have, so that does not really makes matter, and therefore now the building is really easy, and I show it. Okay, so for instance here that is our 68K resistor, and this here is our 470 resistor, and you easily can go and drill it here together like so. Okay, so that is all you need to do. And then the second part you are bringing here into the circuit is simply our diode, and here and there you really need to watch here the orientation. So our black line goes to plus, so you can put it here onto our resistor as we have done it before. And now we need to drill it in like so. And now you already see we have it like here on our planning. So it now gets together, and now simply let's use here our little capacitor, our 100 nanofarad capacitor. But first I have to get it here out of this paper here, and then we bend it over like so, and we take it like so. You get already the idea, I guess. Okay, and we do here exactly the same. Yeah, so that is very, very easy, and you directly see how it really hangs together. And now our next step already is that we finally solder it together. Okay, and now we can already start here soldering it together. So I have here my helping hand, switching in my suction here, and now we can use here a little bit solder, and now it is quite easy. We simply solder it here together, so it is nothing special, and you see we do it of course here on any side, and we do it here as well, and that's it already. Okay, so now we can here cut it a little bit, and you already see that we can use it now as it is, and now we bring in here our transistor. Okay, and you already see that I have placed here our transistor. It is lying here right in the middle, and depending which transistor you're using, you have to put it upside down. The BC557 goes this way. If you use 2N4125, it goes upside down. And now again, relatively simple, we go and bring it in. This again a little bit tricky here behind the camera, but I believe you get the idea, and that is all what we finally need. So yeah, you see now it is already in. It would be easier to have it definitely without the camera, but yeah, you got the idea, I believe. Okay, and to get here the whole idea, I mean, we have to place here on this little diode here to the relay coil. Okay, so we have to solder it down like so. Okay, and then the second step is very easy. So we can place here our little circuit, so our amplifier, we can place it here on our IC. So the not IC, our relay. So our relay will carry our little amplifier circuit, and since we have a plus and ground here connected to our relay coil, we can pick our power supply directly here from these contacts as well, and then we only need to connect here our bypass, and we need to feed finally our relay with the incoming and outgoing signal. I would always recommend here a quarks cable. So this here was a normal quarks cable. So you see that I have taken here it out, right? So that means we have nice impedance matching, and then we connect here input output to our relay, right? And we make here our bridge for bypassing the amplifier, and well, the other both contacts are then our ingoing signal over our little coupling capacitors, right, which has to go here to our little circuit, and we put it simply then here to the contacts. And maybe that now, knowing how to build this little circuit here, now it might be easier to understand what I have done here. So again, this here our contacts on the relay. Here is a coil of the relay, and we simply connect our little circuit over the relay, and we do all the connections as you can see it here on this plan. And you see here the red in and out lines, which is here our coax wire, which is then here going, as you can see it here, to this contact for out, and here on this side it will be in, and of course we will have our in and out if we switch our amplifier in, or we have here a bypass bridge if we want to bypass our amplifier. So that is all you really need to know, and if you follow this instruction very carefully, you are really able to build this here as I have done it, and as it is down in our little fish box here. And therefore maybe this now makes more sense for you. So we have our relay here underneath, and you see here exactly the same components which we have done here. Okay, so here the relay is sitting this direction. Okay, and you see I have used here a 2N4125 transistor, therefore it is upside down, and here on this little build you see it is upside up. And yeah, that now hopefully makes a bit more sense to you, and you are really able to build it with all the hints I have given to you. And once again, if you go really carefully over what I have shown here, the concept in general, then how to connect it to the relay, what do you need to engage our transmit and RX relay with this little circuit here connected to it, and what is finally our amplifier, how is it working, and how can you build it here old school directly onto the relay contacts. And if you take this picture here into consideration to be able to build it, this circuit, and how you can really connect it here to your relay. Okay, and when you use the right wiring, that you have a good matching, then you should really be able to handle it. And therefore you can really build it with not so much money. So all are very cheap components which you can buy everywhere. So no secrets, no expensive components. Everything will be available everywhere. Of course, I've used here different relays. So this is a bigger relay which can handle a kilowatt, and here is a smaller relay than I have shown here. But basically it is definitely all the same. Simply follow the instructions and you see our circuit is working. So we really have a nice synod with our amplifier switched in. So yeah, that's it. Let me stop here. If you like it, please give me a big thumb up. Hope this little project is helpful to you, and yeah, catch you next time. Bye.